All right, everyone, welcome to one last lecture, one last laugh for DAV. All right. Where in the world? All right, usually we do where in the world for everyone. The winners are Derek and Daniel. If either of you are here, please, make yourself known. Okay, well, okay, both of them are actually here, which is amazing, but, they're not making themselves known. So, all right, good work, guys. Thanks for attending the lectures. And the one final, wait, go back. The one final where in the world we have is this picture. I don't know if you guys know where this is or what this is. This is the IEEE lab. And, your one final task for where in the world is to find this here next year. All right, Brandon, take the announcements.
All right, y'all. We hope midterms have gone well. Hopefully you've survived and hopefully there's no more to have to do. Keep your heads up. There's only one more month until summer. So one more month of school, one more month of DAV. And then also we've got an intro to machine learning workshop Thursday, week 7 at 6 p.m. Come out. Travis and Jackie probably have some very good, entertaining machine learning topics to go over. And also we have our new DAV leads with us here today, which is a good thing because that means DAV is going to survive one more year, at least one more year. All right. So with that, we will get started.
All right, guys. So we just wanted to use this lecture to make sure you all know where you should be going with your projects towards the end of the year. And so first of all, just to make sure we all know where we're headed, here's a block diagram for DAV. Okay, this is what you should have. I know we haven't assembled everything together like this yet, but this is, generally the overview of what we're trying to get. You should have, the microphone, which we just did in the previous lab. That goes with the mic translator. And you have your FFT operating on those inputs. And the FFT goes to the Vga module, and the Vga module, puts stuff on the screen. Typo not included. But there's a lot of design space here, and we're actually giving you the option to decide what you want your final product to look like. And so we have put together a couple of different possible endings for you. And it's really up to you and your team to decide how far you want to go and how exciting and crazy you want to get with the project. And we also have different levels of rewards based on what ending you choose. So let's get into it. So the first ending, the first possible ending, the most basic one is the 8-point FFT. So I know in lab 4, we made a 4-point processor. And, low-key, the 4-point processor kind of sucks. So at the minimum, we want you to get at least up to the 8-point FFT. So this is just going to be another stage of complexity on top of your FFT module. It's not going to be anything too crazy. And, this is basically the baseline that we want for you to have when you complete DAV. And if you do this, you get the pride of knowing that you completed our project this year, and you get a cool shirt. Wait, what? Shirt? All right, that's right. If you finish DAV, we're going to send everyone a really cool shirt. And that's because you're really cool for being part of our project. First ever DAV, ever. And so what we're planning on doing is we're planning on just ordering them to the lab so you can pick them up on campus in the fall. This is why that Where in the World is really important. And if you're a graduating senior and you're not coming back, or that doesn't work for you, just let us know and we can just ship it out for you. And if you have any opinions about the shirt, just like, let us know. It's chill. And okay, going next. Second ending is a 16-point FFT. Whoa, another step up from the 8-point FFT, And so that means, instead of not just one extra stage, you have 2 extra stages. And, if you're just planning to do the 8-point one, try to do this one as well, because this one is like, it's not too much of a crazy step up. It's more complex, of course. And the one thing that you should know is that if you don't optimize your code properly, you might have trouble actually getting it to compile. But don't worry, because we checked your code, so that won't happen to you, unless we're bad. But then then there's bigger problems. And so if you do this ending, then you get the shirt, and we're going to give you back all your deposit, even if you had late labs previously. So if you had a ton of late labs and you lost all your deposit, here's your chance for redemption. Because I'm not really interested in keeping your money. I just want to see you guys have a beautiful project at the end. That's my incentive. All right, next, ending 3. If you do anything past the 16-point FFT, then you're pretty cool. That's pretty rad. And here are some ideas of how you can improve your projects after the 16-point FFT. So you can use the RAM that we had in, I think it was lab 5 or lab 6 as an input buffer. So we're not just going directly from the mic to the FFT. We're using the RAM to store our data instead. You can do a 32-point or a 64-point FFT, or you can try a variable point FFT where you can input the number of points you have, and then the FPGA will be smart enough to figure out how to do it by itself. Or finally, you can apply the filtering or the windowing techniques that we talked about in the last lecture. And if you go with this is kind of the big one. Your team gets to keep the FPGA. We're gonna let you just keep the FPGA. You don't have to give it back. You can just play with it, sleep with it, do whatever you want. We assume that if you've worked with the FPGA enough, then you probably have it's probably your best friend by now. You spent so much time with it. We don't want to cause you undue emotional distress by forcing you to part with it. Yeah, so next here is summary meme on the right. If you have any questions about these reward tiers, you should just let me know right now. Let us know, or just message us about it. In summary, 3 prize tiers. Great, okay.
All right, and with that, it's my turn. I'm gonna tell you about some things that you can do to your previous labs that will help you kind of finish off the year with DAV. So basically, we've had you build all 3 parts of DAV in increments in different labs over the course of the year. But to keep things topically simple, we've actually been making them slightly smaller or slightly less complex than they will need to be to do your final 8-point or 16-point FFT, or even more than that. So here are some things kind of to get you started on how to improve each module. So the FFT processor. So from the last lab, you built the mic translator for your digital mic. And if you paid attention, you'll notice that the output is actually 18 bits. But in lab 4, our FFT processor only took inputs of 10 bits. So that means you're going to need to overall increase the size of your inputs and outputs to be 24 bits of data. That also means, since we have 24 bits of real and 24 bits of imaginary data, that your intermediate stages and your twiddle factors will be a total of 48 bits to perform complex multiplication. And since you're adding more stages, don't forget that also means you need to make more twiddle factors because each twiddle factor is dependent on the stage you're in. And hopefully if you don't remember how to calculate twiddle factor, you can go back and watch the lectures on YouTube for Lab 4 to remember how to do it. And then if your FFT processor doesn't have enough cycles, it actually won't work properly. And this is something we kind of failed to take into account with Lab 4. So we talked about how each FFT, each type of FFT has a certain number of stages. For example, a 4-point FFT has 2 stages. But for the FFT processor to work best, you actually should add another stage, which basically catches the value of the final output and stores it into a register to be sent into the VGA module. And there will be more details about this in the spec. So, but just keep that in mind that you might have to add one more cycle than you think. Next, the butterfly unit. So obviously the FFT processor takes in 18-bit inputs. We sign extend them to 24 bits, which means real and imaginary is a total of 48 bits. So that affects your butterfly unit as well, which means they input 48 bits and they output 48 bits. So that also means you need to change the bit sizes of the intermediate wires in your math calculations. So be careful and check those. Next, in your VGA generator. So this one is probably the most different from what you did in Lab 7, which is, So basically the VGA generator is mostly functional, but instead of doing a line graph, because we're calculating 8 or 16 frequencies and just outputting them onto the VGA, they're going to be output basically as a histogram. And so in Lab 7, the design was that we basically took one data point at a time, calculated, scaled it to the VGA pixel, and then turned on the color if we were at that pixel or not. But instead now we actually receive all 16 or 8 or 16 frequencies at once from the FFT processor. So you'll be doing your scaling all at once. And then you'll also need to remap your mic input to your VGA output slightly differently because the input data is no longer from 0 to 4095, it is from 0 to 16,384. And also, instead of doing vertical split screens, we're going to be doing horizontal split screens for the histogram bins, which basically will be a constant size. So that will not need to, the split screens are not a complex scaling equation anymore. Also, we only want to visualize our positive frequencies. So this actually simplifies some of the intermediate math, such as adding an extra assigned bit at the beginning to keep the numbers positive. So that's another change to make. Any questions? We have this all written up in a spec as well. Those are basically the only modules you will need to work with over the next 4 weeks to get this final DAV project working and looking beautiful like this.
Guys, I took this picture and this has been my only contribution to DAV. Is David gonna make us cry now? No, it's against my morals to make children cry.
Oh, it looks like Andrew's already ready to cry. He typed a tear in the chat. Oh, they're calling for a speech.
Wait, why don't you ask this from Brandon, guys? He's a DAV lead too. All right, how about we go to the end first and then we loop back?
All right. So some administrative stuff. We are going to be reusing the parts that we gave you for DAV next year. So if you don't plan on reaching our highest tier reward to be able to sleep with your FPGA, as David so eloquently put, We will be sending out a form later to plan logistics on how to retrieve your parts back. But if you really want to keep the parts, also let us know and we can work something out. Also, we're currently in the process of designing a DAV t-shirt. So if you have any specific thoughts of what you'd like to see, go ahead, let us know and we'll send those ideas over to our great publicity officer, Courtney, and she can get those designs going, preferably within the next week as well, though. And then finally, Lab 8, the final DAV project, so like you said, we have compiled a final spec that basically lists all the tips and specifics to get the entire thing working together as one unit. And so we'll send that out along with this lecture slides and the YouTube video. Don't be afraid to ask us if you need help finishing your project. We're still here for the next 4 weeks as DAV leads us to finish off the year. Also we're gonna have this due Thursday of week 10. And this is a hard deadline because we need to study for finals that next week, so please have it done by then. Any questions about logistics or anything else? All right, with that, it is now time for a David Cow goodbye speech.
Do we have to record this?
All right, I will stop the recording and then we'll have a David Cow goodbye speech.